Hey, what is up? Today we are going to learn a little bit about Spring Cloud Stream, which is a framework built off of the Spring framework that allows us to build highly scalable event-driven microservices. We will be doing this using Spring Boot 3, RabbitMQ, and also Postgres as our database. Now there's going to be three main components for Spring Cloud Stream, which is the source that is the initial starting point where we will be getting data from, and then there's going to be the processor, which will transform or aggregate, filter the data, and then finally we have our consumer, which is the final destination of where the data will go. Now we can build these custom streams and then we can attach it to a tool like Spring Cloud Data Flow, and here's kind of like a data diagram of Spring Cloud Data Flow, and we're going to be building this piece with the source, processor, and sink here. Okay, so the tools you're going to need is RabbitMQ and Postgres. For the RabbitMQ part, if you want to install it directly on your computer, you are going to need Erlang setup, and if you go to this link, which I will post in the description, you can see which version of Erlang you need, which is currently 26 or 25, and then you can install the version tree for it, depending on if your computer is 64-bit or 32. And once you get that installed, then you can run the RabbitMQ setup. Alright, so go ahead and get those things set up and then we will get into it. Today we are going to build a simple stream involving Pokemon. So what we're going to do is we're going to, let's say metaphorically we captured a Pokemon and then we want to either send it to the daycare or we want to send it to our Pokebox, depending on the total power of the Pokemon. So this is going to follow that pattern I mentioned earlier where we have a source, processor, and consumer. So we're initially going to capture the Pokemon, send a REST request, and then we're going to process to see if the power of that Pokemon meets a certain specification, and if it does, we'll send it to the consumer to put that Pokemon either in the daycare or in the box. Now, this is quite a simple idea, but it's just going to give us kind of an idea how to use Spring Cloud Stream. Another idea that I was thinking about, but we're probably not going to do, but let's say if you are an owner of a trading card shop and you receive trading cards from other people who are trying to get rid of their cards. And so initially when they send you their cards, you'll get a REST request sent of the card's details and the card, like what the card is, its rarity. Yeah, the customers will also be sending you the current condition of the card. So if it's in bad condition, you'd probably want to just put it in your shop. But the idea would be that, a consumer or clients could send you an initial REST request, and then with those details, you can process it. In the processor, we would look at like the rarity of the card, the condition of the card, and all that. And then based off those conditions, we would either just, if it's in bad condition, we'd probably just put it up on the shop. But let's say if we found a rare card in good condition, we'd probably want to send it to PSA to do more grading on it, so we could probably sell it for a higher price. So that's another example of how you could use Spring Cloud Stream. And the nice thing about this is once you build these things, you can also use them on Spring Cloud Data Flow. All right, so let's go ahead and get into it and start building out our Pokemon daycare processor. All right, I'll see you there. The first thing we are going to want to do is open start.spring.io, and we're going to select the latest stable version, and I'm going to do this in Gradle, and I'm going to go ahead and fill out these details here. The demo is going to be Pokemon source demo, Pokemon source demo project for Spring Boot source example. And we're going to do this in Java 17. Okay, so we're going to go ahead and add a few common dependencies that we're going to use on all of the source, the processor, and the consumer. Some of these things you might not need, but we're just going to go ahead and add them. So the first one is actuator. Second one, we're going to do JPA for Postgres, and then web, and then Spring Cloud Stream, obviously. So Cloud Stream, and then we also want to add RabbitMQ. We're going to do Spring for RabbitMQ, and then we also want to do Postgres. Let me just make sure we got everything. Another one we want to add is Lombok. And then we can click this explore button to ensure we got everything we need. So actuator, AMQP, JPA, web, stream, binder, rabbit, Lombok, and Postgres. I'm going to be adding 2 other libraries after we get set up, but basically these are the starting point dependencies we're going to be using. All right, so go ahead and generate this project and make sure we're going to save it in a location where we're going to work on in the future. But before I do that, I'm going to create the other project. So processor. So processor example. And everything should be the same here. So go ahead and generate that. And then we're also going to create the consumer. Okay. Consumer example. And then we're going to go ahead and generate that as well. Okay, so what you're going to want to do is, let's open our File Explorer, and I'm going to get everything I downloaded and save it in a location that I will be using in the future. Here, Spring. I'm going to go ahead and put it in here, and then I'm going to extract the data. So I'm going to grab this, Control X, post it in here. Source, processor, and also the consumer. All right, and then I'm just going to delete these zip files because we don't really need them anymore. Now that we have the initial project set up, I'm going to go ahead and open it up on my IntelliJ. So I'm going to go to File, New Project from Existing Sources, and I'm going to go ahead and locate the file location. So that's going to be in my Documents. Let's go to Videos, Spring, Source Code. So I'm going to import the source first. Just open this up, make sure we got the Gradle build. Okay. Select Gradle, create, trust this project, new window. And I'm going to import the rest of the services. So new module from existing sources. We're going to select the processor, Gradle, create, and then another one, new module from existing sources, and consumer. Okay, so now we got all three of these in here. I'm going to start on the source one, and then we're going to work our way source, then processor, and then finally the consumer. So the first thing you want to do is go into the build.gradle file, and I am going to add a few more libraries that are going to be able to help us with our project. So first I'm going to go to this ext part, and we're going to set some more libraries up. So set Spring, and let me zoom in here so we can see. Spring Open API Web MVC version, and that's going to be 2.6.0. And then also another one we're going to use is Apache Common. In that version, we're going to be using 3.14.0. Okay, and then I'm just going to go ahead and add them in here. So, implementation. It's double quotes for this one, org dot spring doc slash open API slash starter web MVC GUI, and then we're going to put in that version we set up above. Okay, and then I'm also going to add the Apache library implementation org.apache.commons commons-lang 3, and we are going to import this here. All right, and then we can do that to bring them in. So I know I typed these out, but you can also find them online. So if you go to like Maven repo, come on. Why is it, no, Maven repository. You can find them here. You can just search like Apache common, and there should be lang 3 somewhere here. Lang 3. Yep, right here, Apache Commons. And then also we're using the Spring doc open API. Spring doc open API here. And they will show you how to set that up. But we'll also set it up on this project, so you don't need to worry about it too much. All right, so before we get started, I'm also just going to copy these extra libraries to the consumer as well, just so we have them. So go into Pokemon Consumer, and then the build Gradle, let's just go ahead and add them in while we're here, so don't forget. Go to this build Gradle and just add that in here as well. Go ahead and save that. Now what I want to do is let's set up the resources we're going to need, the application resources. So let's go into main, source main, and then we can get rid of these two here. And we can just rename this one application.yaml. Okay. So let's see here. That should work. And then we want to set the port server, port, and then I'm just going to use 9002. And then we're going to be using Postgres for our database, so I'm just going to set up that connection here. So Spring data source URL JDBC Postgres QL Postgres QL, that looks right. Localhost, and then we're going to create a we are going to create the database. So captured Pokemon, and then demo. We'll just call it captured Pokemon DB, and then the username. So I'm going to add some environment variables, but we're also going to set some default values. So if you have different ones, you might want to change it depending on what you set your Postgres to. So Postgres username, and then the default is just going to be Postgres, and then the password, Postgres password. That is also going to be Postgres. Okay, so the next thing I'm going to do is have JPA auto-generate some of our tables that we from the entities we're going to be making. So generate DDL true, and then we're just going to set show SQL to false for now. All right. So I think that should be fine. One other thing I want to set up is let's set up the RabbitMQ as well. So RabbitMQ. So for Spring Cloud Stream, you usually don't have to if you're using default stuff, but it's good to set this up. So host name, we're just going to use localhost, and then the port is RMQ port 5672, and the username RMQ username, and for the local host, it's just going to be guest. Password RMQ password guest. All right. So that should be good enough for our initial setup. Okay, so I'm going to go ahead and try and test this out to see if we can get it to run with these properties. So I'm going to go to the application and click on this run button here. See if we get any issues. Okay, so it looks like we got an exception, unable to create request service, JDBC environment, unable to determine dialect without JDBC metadata. Okay, so this is common. Sometimes you might need to set the dialect, but this is happening because we forgot to create the actual database inside of Postgres. So what I want you to do is copy this database name, and then we're going to go into pg admin. So let me just close this and open it up. pg admin, get Postgres started up. And so whatever you set up for your Postgres, you want to put it inside the username password here. Once you get Postgres opened, it should look like this. We're going to click on the server area, and it's going to request for the password, so that should be Postgres. And you can see I did a little bit of demo here, so I'm going to go ahead and right click on this database and then create the database. We're going to paste that name we created. So captured Pokemon DB. Owner is Postgres. Go ahead and save that. So once you have that, let's go back to our project and try and rerun it again. So I'm going to go back to the application and then run it again. Let's see if it will start up successfully this time. All right, so it looks like we have a successful startup. Now we can get to work. I am going to create a few packages here, and this is where we are going to place our code. So the first one's going to be the controller, and then create another package called the DTO, another one for entity, and another package event, gateway, repository, and the last one is going to be the service. Okay, so we got the packages created. I'm going to go into the controller and create our first class, which is going to be the Pokemon controller. Okay. All right. So we're going to go ahead and create the controller. What I also like to do is just create the entity as well. So I'm just going to go into here, create another Java class and call it Pokemon. And we're going to add a few details. Let's add some Lombok annotations. So no args constructor, let's add a getter, setter, basically creating a POJO. And we're going to mark this as an entity because we're going to persist it to the database, and we're going to give it a table. The table name, we're going to name it to Pokemon captured. All right. So as with most tables, we want to set up a initial ID, column name, column, we're going to make it not nullable, and then we're going to automatically generate the values for these IDs. Generation type, identity, private long ID. And what I'm going to do is just copy this the CSV I got offline, and I'm going to be posting it in the GitHub page. But we're just going to be using the properties that we find inside of this CSV. So another thing that we could have done with Spring Cloud Stream is we could have had our source as like taken in CSV files. But for this example, I'm just going to use a REST request. But I'm going to get these properties here, and I'm going to put them into our entity. So we're going to go private string name, private string type 1, private string type 2, private integer total. And this total part is basically what we're going to be using in the processor to determine if we're sending it to the daycare or not. HP. back. It's integer speed nations boolean dairy private boolean processing status and private string its ID. Okay, so you could also add some other variables in here, but I'm just going to keep it simple. Other variables that you might want to add is maybe like a nickname, or also like the sex type, is it male or female? You could add other variables in here. But I'm going to go ahead and save this and then rerun the application. And what this should do is it should create a new table inside of the Postgres database. Let's see if that happens. So it looks like we started the application. If I go to Postgres, let's look at the Capture Pokemon DB schemas and tables. We got a new table here for Capture Pokemon, and I should have all those variables we set. So let's see, run a select, and there we go. Yeah, so we got the ID, the attack, defense, everything we added, created. So looks good. Okay, so we got the entity created and it's showing up in our database. I'm going to go back into the controller here and we're going to start creating that REST endpoint where we will be accepting these requests and we are going to process them. I'm going to use the all-args constructor so we don't have to do like the Spring Boot auto wiring stuff. Yeah. REST mapping, request mapping. We're going to just set this to Pokemon. And I'm going to be using the Swagger annotations. Name. Controller. Okay, so basically this controller will only have one endpoint, which is a post for captured Pokemon. So I'm going to create that real quick. So public response entity, and it's going to just return a string value, captured Pokemon request, and in the request body, I'm going to create a DTO for Pokemon request. We're not going to have it yet. And we're going to create those pretty soon here. I'm just going to add this annotation for request mapping, or not request mapping, post mapping. And I'm going to set this to captured. Import this request body from Spring Framework. And we're also going to use a service, so private Pokemon service, Pokemon service. All right, so I am going to create the DTO first. So if we hover over this, we should be able to see create Pokemon class. I think if I press Alt Enter, we'll get all these other options. So I'm going to create the class, and I'm going to put it in the DTO. And let's go into that DTO spot. So Pokemon request here. And we're going to add some annotations. So getter, setter, and then also the builder. Pokemon request at non-null, private, string name, non-null, private, string type 1. So these variables are pretty much going to be the same as our entity. So if we go side by side here, they're pretty much going to be the same. I'm just going to copy them just to make it easier. We just want to check some stuff to make sure it's not null, just for demo purposes. Okay, and then I should be able to just copy the rest of them. So yeah, the main difference is we don't have this processing status in the reference ID. That's because we're going to be using these two in our stream to track the status. Okay, so I'm going to go ahead and close that. Save this, go back to our controller. We need the service as well, so I'm going to go ahead and Alt Enter. Let's create a class. Usually I like to set up my services as an interface and then have implementations of those services. But I'm just going to make a simple service for now. So we create a new service here. Let's go down here. Okay, we got the service. And we are going to get that all set up. So at service, and then all args constructor, and then SLF for J for logging. Yeah. Inside of our service, we're gonna have a private Pokemon captured repository. And I'm gonna go ahead and create that repository as well. So Alt Enter, create the class repository. And this is actually supposed to be an interface, so interface, then make sure that's good. And it extends JPA repository. The type is going to be the Pokemon, and we're going to have a long ID. Should be good. Okay, we also want to annotate this with the at repository, and I'm going to add a custom query using JPA repository. So we're going to get a list of Pokemon, and we're going to find the Pokemon by processing status, and we want to find the Pokemon that haven't been processed yet or haven't been sent to like our box or daycare yet. Processing, and we're going to import this list. Okay, so that looks good. Now we're going to build upon our service and controller. Should be getting less errors now, so I'm going to go back to the controller, and we're just going to add a few open API Swagger stuff. So description, handles, captured Pokemon, and places them in the Pokebox or Pokemon daycare. period. I'm also going to add an API responses with a S. Give it some values. I'm going to add the first one, API response code of 500, and the description, internal server error, and another one, API response code 200, description, just do success. All right. So we got that all set up. The next thing we're going to do is fulfill this request. All right. So when we get this new Pokemon request, we are going to validate it first. You can also do this in your service. I like to keep my controllers pretty clean, but for this example, I'll just Apache Commons. We'll just do some validation here. I'm just going to check for empty values. So we're going to do Pokemon request get name, and we want to check if they're empty or not. What the heck? String utils dot is empty. Get type. And also one last one, which is Pokemon request get total. We want to make sure the total is greater than 0. All right. So should be everything. Let's create some curly brackets here. And if we get any of these, we want to return a bad request. So response, entity, bad request, and build that to send it back to the requester. If everything is good, then we are going to save this into our database. So optional, Java util optional, okay. And we're going to get a string back to Pokemon reference ID equals, and we're going to go into the Pokemon service and we're going to create a new method, save captured Pokemon request, and I am going to want to create this method here. So we can either go over it with our mouse and it might ask us, or I should press Alt Enter, and we can create the method here. So we're going to create that method. I'm going to leave it for now and come back to it later. Finish out this controller first. So we're going to return Pokemon reference ID, and then we're going to map the Pokemon reference ID, and we are going to get a response. Spelled it wrong. Response entity dot status and HTTP status created, and then add to the body. So this is the string we're returning back to the user. Your Pokemon reference number is plus Pokemon reference ID, and or else if we don't get anything, we are going to do a response entity status of HTTP status internal server error dot build. Okay, so should be good enough. Let's see here. Just clean this up a little bit. Okay, that looks good. So the next thing we want to go into is our Pokemon service here. And we are going to fill out how this captured Pokemon is going to be done. I'm gonna wrap everything we're gonna be doing in a try catch. We're gonna catch any exceptions. And we're gonna log them first. Exception.getMessage. And we're gonna return an optional of empty. Okay, if everything goes good, should be creating a new Pokemon in that database table. So new Pokemon, and we're going to use the bean utils to just copy everything from the Pokemon request to the new Pokemon. So copy properties. So we got the Pokemon request, and we're going to copy it to that new Pokemon. And then we're going to set Pokemon.set processing status to false, so it hasn't been processed yet. And then we're going to create a random reference ID. So set reference ID, and that's going to be random string utils random. I'm going to make it 10 digits long. We're going to use letters. We're also going to use numbers. Okay, and then we are going to save this Pokemon into our table. Pokemon saved equals Pokemon captured repository, save that Pokemon, and we're going to return it back. We're going to return that reference ID back. So Pokemon saved dot get reference ID. All right. So that looks good. I'm going to go ahead and save all of this and then just rebuild the project so we can test it out. All right. All right. So project started up successfully. I'm going to open a new browser, localhost 9002, and then the Swagger default page should be swaggerui.html. All right, so it looks like we were able to create that endpoint successfully, and I'm going to test it out, try to add a new Pokemon. Basically, you could just put whatever you want in here, but I'm going to use that CSV, and I'm going to just do the first entry for Bulbasaur. Kind of have one of the JSON values saved here. You can put whatever Pokemon you want. Yeah, let's just make sure everything matches up here. So we got total 318, yep. Everything looks good. And I'm going to go ahead and execute this request. All right, so it looks like the response was successful. We got a 201. Okay, might need to change that in the future. The reference number is optional. That doesn't look right. Let me see if I can, if that is right. Let's see. Um, do 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 do. Should be right. Reference number. Oh, it's supposed to be this. Okay. So I'm gonna go ahead, save this, and restart. And then we're gonna just make a request again. Same Pokemon. Go ahead, execute it, and yeah, your Pokemon reference number is that. And if I look at the Postgres to confirm this, so we got the select method running on our captured Pokemon. Run this, and we got 2 entries for Bulbasaur here. We can see the processing status is false, and that's what we're going to be working on next. This is where Spring Cloud Stream comes into play. We're going to look at all the Pokemon that haven't been processed yet, so everything that's false, we're going to capture all those falses and we're going to run them down the stream to either send them to the daycare or to our Pokebox. Okay, so first thing we are going to do is just create some events. Since this is event driven microservice, the first event I'm going to do is new Pokemon event. I'm also going to create another one that holds the Pokemon details. So let's see, new Pokemon event. It's actually going to be a record, and it's going to hold a list of Pokemon details. Pokemon detail list, and we want to import that. Yep, looks good. And then inside the Pokemon detail is pretty much going to be the same as our other entities. So we could probably just, reference our entity here. So I'm just going to split this to the right and add a getter, add a setter, add a builder, no args constructor, and an all args constructor. Might want to add these because Spring Cloud Stream definitely has some issues with object types. But yeah, I'm going to copy all of this stuff, except we don't need the processing status. So we need everything except the processing status. So let's delete that. We're going to carry the reference ID so trainers will know if their Pokemon made it to the Pokebox or the daycare based off the reference ID. All right, so we got all the events set up, new Pokemon event, and we also got the Pokemon details for each event. Now, what we need to do is create a gateway, and this gateway is where we're gonna be doing all of the whole stream. So I'm gonna call this Pokemon event publisher, and we're gonna add some logs just in case we need to. Add an all args constructor, and we're gonna do a configuration. Okay, so we're also going to create a new service. So Pokemon event publisher service. We will create that right now. So Alt Enter, create the class inside of our service. And we will work on this service later. For now, I'm going to go back to the gateway, and we are going to create basically our bean for the stream supplier. So public supplier, and you want to make sure it's a Java util function here. New Pokemon event, so that new event we created, and we're going to publish new Pokemon event. So whatever you name this method, you want to keep tabs of it because we're going to set it up in our application YAML, which we will do near the end here. So I'm going to return a function of optional new Pokemon event. And we're going to use that new service we're going to set up, and we're going to publish a new event. And then after that, we will return new Pokemon event that we get from that service, or else we're just going to return null. Okay, that looks good. I'm going to go ahead and create this new method here inside our Pokemon event publisher service. So this is going to be a bit long, but what I would like to do is we need the repository as well. So private, and we're going to add some annotations here, SLF for J. I'm also going to add the all args constructor, so we don't have to do that auto-wired annotation for Spring. Pokemon captured repository, and we got this optional new Pokemon event. All right, so what we're going to do is we're going to get the list of Pokemon that haven't been processed yet, and we're going to find them so we can send them off for processing. So list Pokemon list, import that, import the list, equals Pokemon captured repository dot find by status. So if they haven't been processed, they have that processing set to false, which we can see here, processing status of false. Next thing we want to do is put that in our Pokemon details Pojo created. Pokemon details equals Pokemon list dot stream map Pokemon inside of there. We're going to use our bean utils to just copy it again. Bean utils, copy properties, Pokemon detail. Oh, forgot to create a detail. So Pokemon detail equals Pokemon detail builder. Okay, we're just going to copy whatever we get out of this request, this list of Pokemon, we're just going to copy it to the Pokemon detail. And then we're going to set the processing status to true. Pokemon set processing status true. And then we're going to return the Pokemon detail. And we need to set this to list. So that'll give us the Pokemon details, which we are going to add to our event. Now what I want to do is, just so we can see what's happening, we're gonna see how this streaming kind of works. And what it does is it just constantly checking the database. So what's happening is it's going to be running this request multiple times, being like, has there anything changed? Are there new Pokemon to process? And that's basically what the source does. It's just constantly checking to see if something's changed. All right, for new Pokemon requests, available records process. Let's see here, Pokemon list signs, okay. Optional. I create a new Pokemon event. To publish equals a empty optional. We're going to start out with something empty. And if the Pokemon details is not empty, then we're going to send it off downstream to our processor to determine if it needs to go to the Poke Center, or I mean the Pokemon Daycare or the Pokemon Box. Updating Pokemon status as processed. Some of that so we can see what's happening. New Pokemon event. We're going to create a new Pokemon event, and we're going to add the Pokemon details inside of there. I'm going to set this to new. And then in the Pokemon captured repository, we want to save everything. So Pokemon list. So right here we were setting the process to true. So we want to save that into our database. And then we're going to return event to publish. Okay. So yeah, basically we're gonna, if we find new Pokemon that haven't been processed yet, we're gonna put them in the details list, and then we're gonna create a new Pokemon event, and we want to make sure the event to publish here is populated so it's not empty. Optional of, and then the new Pokemon event. So what's going to happen is the publisher is going to be constantly running this request, and we'll see that happening, and it'll be checking the database to see if there's any statuses that it can process. Before we can actually have that happen and have it send it off to RabbitMQ, we need to update the application YAML. So what you want to do is you want to make sure you copy this method, because we are going to be using it inside of our properties. So right under JPA, we're going to add another one. So cloud, stream, bindings, and then we're going to paste that, and we're going to send it out. So like as described in the picture, we got the source, we're going to send it out so our processor can pick it up. Out -0, and then destination Pokemon processing, and this is going to be the exchange name. And so Spring Boot's going to be creating these exchanges and queues for us in the background. So that's kind of nice. So we're going to group this in homing Pokemon. So throughout this Pokemon, the setup, we will be using the homing Pokemon group. So I'm going to go ahead and save all. I think that's everything we have set up. Let's go ahead and test it out. So what I want to do is also open up my RabbitMQ. So at localhost, yep, gonna make sure we got RabbitMQ. Okay. So we got a lot of exchanges set up, but we're gonna have a new exchange set up for Pokemon processing, right? And yeah, so I'm gonna go ahead and run this. And it's gonna happen so fast that we probably might not even see the messages. But yeah, so you can see right here, it found 2 available records to process. And it processed them, it sent them off the queue. And now we can see, now it's just checking every so often and it's not finding anything ready for processing. So it's just going to keep running and waiting for something to come in. So let's say if I send another request, I caught another Bulbasaur. Let's just execute this a few times. If I go to the logs, we're going to see it's like, oh, we found some more to process. I'm not sure if we're going to be able to see the messages on RabbitMQ, but yeah, we can see that it picked up some. Yeah, and then we can see we have three messages ready for the processor to pick up. And that's what we're going to be doing in the next part is we're going to be working on the processor. All right, so I'll see you there.